Welcome to Ask and Learn.
Here we're given several interrelated equations having to do with the theory of relativity, and our goal is to show that this equation is true. So we're going to take the force equation we were given. Force is the derivative of mass times velocity. We're going to substitute the mass equation in for m, and we're going to find the derivative. Now keep in mind that as we're finding the derivative, our variable is not v, our variable is time, t. So let's find the derivative of mass times velocity. If mass is actually m naught over the square root of 1 minus v squared over c squared. So we're multiplying that by velocity. We're going to find the derivative of it. Okay, so because this is a quotient, we're going to use the quotient rule. So we have the bottom, square root of 1 minus v squared over c squared, times the derivative of the top. And the derivative of the top is going to be m naught times dv dt. Remember, our variable is not v, our variable is t, time. And then we have minus the top, m naught v, times the derivative of the bottom. And because the bottom has a square root, we're going to bring down the 1/2, and we are going to raise the inside to the negative 1/2. And then, using the chain rule, we're going to take the derivative of the inside, which would be negative 1 over c squared times 2v, times dv dt. Remember, chain rule, v is not our variable, t is our variable. And this is all over the denominator squared, and so we're squaring the square root, so it's all over 1 minus v squared over c squared. Now, obviously, we have a lot of simplifying to do until we get to what we were hoping to show, and one of the things we can do is replace the dv dt with a. Remember, a is dv dt. Acceleration is the rate of change of velocity, so we have two places where we can do that, and then we're going to be looking for other ways that we can kind of clean this up a little bit. For example, we have a 1/2 right here, and down the line a ways it's being multiplied by 2. So those will cancel. Okay, so let's see what we have now. So in the first term, we have m naught times a. Remember, we replaced the dv dt with a, times the square root of 1 minus v squared over c squared. Then in the second term, we have plus, oh yes, because we have we have minus a negative, so we can make it plus m naught times v times another v. See, we have a v here and another v here, so times v squared times a times 1 minus v squared over c squared to the negative 1/2. Let's see, did we get everything? We still have this 1 over c squared. We haven't gotten that yet, so we'll write that as over c squared. And that whole thing is over 1 minus v squared over c squared. All right, next. It sure would be nice if we didn't have this negative exponent in here, and if we didn't have fractions inside our fraction. So the way we can deal with that is we can multiply the top and bottom by the special form of 1 minus v squared over c squared to the 1/2 power. That's the same as the square root when you say it to the 1/2 power. Okay, so we're going to distribute that through both terms of the numerator. We're going to multiply it by this term, and we're going to multiply it by the last term as well. And so when we multiply the square root by the same quantity to the 1/2, it's just like having it to the first power. It's to the 1/2 multiplied by to the 1/2, it's to the first power. So we have m naught a times 1 minus v squared over c squared. And then when we multiply these two together, add the powers and you get the 0 power. So essentially they cancel. So what we have left is plus m naught v squared a over c squared. And that is all over 1 minus v squared over c squared to the 3/2 power. Okay, the next thing we can do is distribute our m naught a and multiply it by 1 and multiply it by v squared over c squared. So we have m naught times a minus m naught times a times v squared over c squared plus m naught times v squared times a over c squared, all over 1 minus v squared over c squared to the 3/2 power. And do you notice that these two terms here are opposites, so we can cancel them? So what do we have left? We have, remember this was equal to the force, we have the force equals m naught times a over 1 minus v squared over c squared to the 3/2 power. And that is exactly what we were asked to show.